Static electricity. The electricity that does not move. It remains standstill in the object. Static electricity is the imbalance of electric charges within or on the surface of the material. This imbalance occurs when there is a difference in the number of positive and negative charges. It's called static because the charge does not move or flow like in a current. Electricity in nature. The most common electrostatic phenomena is observed in nature during the lightning. In the same way, we have daily like examples like rubbed balloon sticks to wall, the comb which is used, it gets static charge and attracts the hairs or bits of papers. In the same way, when we hold knob, doorknob, which is made up of metal, we get electric shock. There are uses of static electricity. The common use is photocopying, printers, etc. Now you can see the balloon is being rubbed against the hair and it sticks to the wall. How it works. Electric charge. In order to understand this, we have to understand the basics of an atom. Electric charge can either be positive or negative. In an atom, electrons have negative charges and the protons, they have the same but positive charges. The amount of charge on proton and electron is same, but the magnitude is same, but the signs are opposite. Neutrons have no electric charge. So it means an atom is electrically neutral because a neutral atom has same number of protons and electrons. Electrons revolve around the nucleus and protons and neutrons stay in the nucleus. Static and current electricity. Static electricity describes the situation when an electric charge remains stationary. This occurs best with insulators. It means insulators get static charges. And electric current occurs when electric charges are moving from place to place, and this happens best in conductors. Charging material using friction. When certain insulating materials are rubbed against each other, they become electrically charged. Electrons are rubbed off one material to another. The material which gains electron, it becomes negatively charged, whereas the material which loses electrons, it becomes equal and opposite, that is positive charge, because there will be lack of electron in that material. So here the perspex rod, which is rubbed against the cloth gains electrons from the perspex rod, causing it to become positively charged, whereas on gaining electrons, the cloth becomes negatively charged. So when a charged object is brought close to an uncharged one, the two objects attract each other. You can see the rubbed comb can attract the water towards it. In the same way, balloon, which is charged during the friction, it is attracted towards the wall. The rod is being rubbed with the cloth and it loses electrons, which are transferred to cloth, to causing it to become negatively charged. Whereas on losing electrons, the rod becomes positively charged. When a positively charged rod is brought close to a suspended similarly charged rod, what do we observe? Repulsion. Amount of repulsion depends upon the size of positive charge. The greater the charge, the greater will be the electrostatic force of repulsion between the two similarly charged rod. In the same way, when a positively charged rod is brought close to a suspended negatively charged rod, what is observed? Attraction. It means unlike charges attract. Two bodies that, which carry different types of charge, they attract each other. And same charge, they will repel each other. So the law of charges, like charges repel, unlike attract. Like the boys here, they have similar charge, so they all erect and stand away from each other because the type of charge on each strand of hair is same. Here there are suspended rods shown, and we can see the positively charged rod is being repelled by another positively charged rod. In the same way, negatively charged rod is repelled by another negatively charged rod. And a positively charged rod is attracted towards the negatively charged rod. Here, the strip of paper is being rubbed by hand. On rubbing, the two sheets have similar charge, so they repel. Let us try once again. They move apart means they have similar charge. When hand is brought in between, they stick to the hand, they cling to the hand because on rubbing, the hand acquires opposite charge to that of the polythene. Electrical conductors and insulators. An electrical conductor is a material through which electric current flows easily. All metals are conductors. Electrical insulators have a very high resistance to the flow of electric current. There are examples. Rubber, what it is? Insulator. Steel, conductor. Mercury, conductor. Paper, insulator. Plastic, insulator. Diamond, insulator. Graphite, conductor. Both insulators and conductors can be charged, but insulators will hold the charge, whereas conductor will transfer its charge to the surrounding. The difference is what? When you place the charge on on an insulator, the charge will stay there at that position. Like at this point, the charge, this insulator is given positive charge. So this part of the insulator remains positive. The positive charge will not move. Another positive charge is given to another place, and this will remain at this place. It will not be moving. Whereas a charge is given to conductor, it will move throughout the body of the conductor. And conductors cannot be charged easily by rubbing because they transfer charge from atom to atom, and on shaking the conductor, that can be transferred to the surrounding air, or if it is earth, the charge may go to earth. So this is a conductor and this is a cloth, and the cloth is being rubbed. The cloth acquires positive charge and the conductor acquires cloth gets negative charge, and conductor acquires positive charge. And see that this charge is moving from atom to atom. When the certain atom becomes positively charged, the electrons from the neighboring atom come and make it neutral, causing the neighboring atom to be positively charged. This is how the positive charge shifts from one end to other end, and if it can be made neutral by taking electron from the surroundings or from the earth. Now we have some fill-ups. Static electricity occurs when electric. We have to choose from there. What comes in the first blank? When electric dash remains dash on an object. Electric charge remains stationary on an object. And dash object can be charged by dash it with another insulator, one of them gains dash and becomes negatively charged, the other becomes equally dash charged. Let us see what comes. An insulating object can be charged by rubbing it with another insulator, like ebonite is insulator, cloth is insulator. So when they are rubbed against each other, one gains electron and becomes negatively charged, the other one becomes positively charged on losing electrons. Electrons then becomes negatively charged, other becomes positively charged. The law of charges states that like charges repel, unlike charges attract. That's all. And in the next video, we will study about the uses of and hazards of static electricity. Till then, Allah Hafiz.